Hi, we're here with George Rueter from Atmel, and George is going to give us a glimpse of some next generation electronics for car access technology. George, talk to us a little bit about what we have in front of us here.
So what we have here is a chipset that implements a passive entry, passive start solution where you have a key fob in your possession and you have the ability to unlock the car and get in and start the car, and the key fob stays in your pocket. So we have a 3-chip solution that implements those features, and I have a demonstration of that chipset and its capabilities here. It operates on this tablet. But first we have the remote keyless entry, which is a fob, and that operates in the traditional fashion. You push a button and the car doors are unlocked, and you push another button and the car door is locked. So that's kind of the last generation technology for car access. This allows you to keep the fob in your pocket and push a button on the car, and this circuit board represents the car. You push a button and the fob stays in your pocket, and you can see it detects the fact that the fob is outside and unlocks the car doors. So then you get in, keep the fob in your pocket, push a button on the dash, and the car starts.
Well, the point being that you could do it either way. It's up to you.
Right, exactly. And the most convenient way is to keep the fob in your pocket and the automobile starts. I would also mention that it's a very secure, authenticated, encrypted communication. So you can be confident that only the rightful owner of the fob can get in the car and start it. So
this kind of appeals to those of us who don't really trust keyless entry.
That's very true. So it's a 3-chip solution that implements this. We have a radio frequency chip at 433 megahertz and low frequency chips that operate at 125 kilohertz. So,
what was the advance that allowed you to do that over today's technology?
It's the low frequency, the 125 kilohertz. This allows the fob battery life to be extended up to 5 years. I mean, you can't use an RF because that would consume the battery in the fob prematurely. So it's also has the ability to fairly precisely locate the key fob, because there's a safety concern that you don't want the car to start if the fob's not in the car. For instance, if a mother puts an infant in a car seat and is walking around the car and the infant pushes the start button, you don't want the car to start. So it allows a fairly accurate location of the fob. Typical implementation has up to 6 LF antennas, 1 in each door handle, 1 in the trunk and 1 in the center stack. So it's quite a complex system, and a lot of software is involved, a lot of system level type decisions.
When can we see this in production vehicles, do you think?
This year sometime. So we just introduced the 3 chips, and so you should coming soon to a car near you.
That's great news, particularly for those of us, as I say, don't really trust those keyless fobs.
Yeah, that's correct. So,
Thanks, George.
Oh, my pleasure. Thank you.